Okay, so this is all in the past. I'm here to talk about the future. Let's talk. This is the recent past. So if anyone's on a version that's more than a year old, you're missing out on all this stuff. But let's talk about the future now. Looking to the future, all the pictures are the same because the things we care about don't change that much. We always care about these three things, but the items do. So on the performance side, full vectorization. So vectorizing the remaining query engine. The big one is top N and scan are not vectorized yet. So full vectorization. For the group by engine, we want to implement a streaming group by. So right now we have array-based group by and hash-based group by. But if you're grouping by the same column that your segments are sorted by, you could in principle do a streaming approach. And so we'd like to do that for those cases. And reducing thread contention, making it so this is something that doesn't matter very much if you have relatively small servers, but if you have really big servers with 96 processors or whatever, then there's so many processors that thread contention can start to be an issue at those very large server sizes. And we've got a bunch of ideas for how to reduce that in future versions. Indexes for numeric columns. Right now, string columns are indexed, numbers aren't. Enough said. Sorting by dimension and not by timestamp. Today, everything is always sorted by timestamp in Druid. But for IoT and sensor data, you actually want to sort by dimension. You want to sort by the name of the time series or by the sensor that delivered the data and put all the data for the same time series together. So for that kind of data set, we can get performance boost by sorting by dimension. You actually have there's a pretty cool workaround you can do today where you set your timestamp equal to the segment granularity. And then you have a secondary timestamp that's the real timestamp. And for IoT data, this actually speeds things up by almost 10x, which is really cool and a little bit fiddly to get done because you end up having two timestamps and doing funny things with query granularity, and your queries look a little weird, but it's 10 times faster. And anyway, we want to make that possible without having to do all these funny tricks. Moving on to functionality. Someone asked a question about joins. Today we do have joins in Druid. We shipped it within the past year. And the join functionality we have today is really designed for a star schema type situation and for joining against subqueries where the subqueries are modest size. So, for example, let's say you want to do a subquery that selects 10,000 user IDs and then filter on those 10,000 user IDs. The join system we have today is perfect for that. Let's say you want to use a join to implement a star schema where the right-hand side dimension tables are whatever they're going to be. Works well for that. What it doesn't work as well for is a fact-to-fact join or a join against a really massive subquery that has 20 million rows or whatever. So that's something looking towards the future that we'd like to do. Ever larger subqueries as well. So the subquery system right now, like I mentioned, works really well when the subquery results are relatively small, but we would like people to be able to do subqueries with massive results and still have it work quite well. And the window functions and aggregations. Don't support them today, but they're really useful for stuff like moving averages, cumulative sums, percentage of total, so on and so forth. And so we want to add those. Finally, on the ops front, what we call the big indexer. So those of you that are deploying Druid today know that when you, the way that ingestion works is you have there's basically a task system where ingestion tasks run, and each task has its own JVM. And this is really good for isolation, but it is not good if you have a lot of really small tasks, if you want to load a lot of small tables at the same time, that kind of thing. So for those kind of situations, we are redesigning the system such that there's one JVM that can run a lot of tasks in the same JVM, being better usage of resources, share resources better. We call it the big indexer. It's actually in Druid today. The next release, 021, is going to fix the last remaining known critical, I would say, like blocker bugs with it. There's still some feature gaps that we're not going to make it the default in 021, but you can start playing with it in 021, and it does work, and we are using it in production at Imply. Simplified memory management. moving more things off heap. That's part of that concept of having fewer tunables. And simplified native batch tuning, fewer tunables, trying to get all the way down to 0, or as close to 0 as we can get. All right, that's it for the roadmap.